very lucky today. For the price of one session, you get 2 Zen Masters. Woo! So,
And there's
well, yeah, but they're not gonna speak. You guys are our focus, right? So I hope you are all having a wonderful start to your TC experience. How many of you are first-time TCers? Sweet! Welcome to a wonderful week. We love this week. I look forward to it every year. I am Stephanie Potter. I am a senior product manager at Tableau, and I am thrilled to be able to introduce Anya and Alan. So Anya Ahern is the founder of DataBlick. Yes, exactly. We have a row of plants in the front. We're gonna cop to that. So when they scream and holler, it's your turn to scream and holler. Interactive session, right? I see a few nods and a few no's.
Kind of.
Okay, fair enough. You don't have to. So Anya Ahern is, like I said, the founder of DataBlick, and they are a boutique company that specializes in making actionable data art. And wait for that to sink in. Actionable data art. No, actionable. That's the actionable. I'm a big proponent of action because it helps you move things forward. So, and a lot of her data vises on Tableau Public really focus on showing how the underlying data can reveal socioeconomic trends, which is totally cool. Then we have Alan Walker, who is, I have to say, a data mapping guru. And I do not use that word lightly. So his work with the Visualize No Malaria campaign is really helping drive forward results in Kenya, and I'm sure that he's going to talk about that more later today. And if you go out on Tableau Public, he's got a whole bunch of visualizations that show you the ways in which mapping can be used to represent data. Which brings us to this talk. And here we're going to talk about why the where in data really impacts the context and the ability to impact the world around us. So it is with great pleasure that I welcome Anya and Alan.
Thank you.
Thank you.
All right, thank you all for coming. Let's get ready to make some geospatial love. Woo! All right, she already did that for us, so we're actually cartoon characters, not actual people. We just wanted to plug some of the related sessions before we get going. We have Christy Martini and Tomas Foldy in the front row presenting right after this, so get up and run to their session. And I'm also keynoting the Data Plus Women meetup later this afternoon. And then there's other just fabulous sessions, so those are all wonderful ones. Take a picture so you remember to go to those. Cool. But we are here today to talk about why where matters. And so we always get these data sets that we play with all the time that are standard, and we generally know a little bit about the who, right? We might know a customer ID, we might know the gender, we might know some age, but usually we know very little about our customers initially, and we know what the customer did, so we know transaction data. If they went to a restaurant, they bought a widget, they swiped right. And we also might know some when information. How often do they do this? Is it a pattern? What is their lifetime value? But the second you put a dot on the map, there is a treasure trove of data and information that most people don't realize that you can take advantage of. Just by putting that dot on the map, we might know weather. We might know whether it's an urban or rural area. We might be able to assume the income or the ethnicity, or just other information about where that dot on a map is. So our goal today is to kind of talk about open source tools and just give some examples of the data that you can use to enhance your analysis and ask more questions. And we're going to go through 7 use cases. And our first one, we're going to go very slowly. But then we're going to get a lot quicker. And our first example is focus on healthcare facilities. And we want to understand that connection or that relationship between the hospital and the community that it serves, with our goal of trying to make healthcare more accessible and customizable to patients and their needs. And so every one of our examples will start with a dot on a map. Anyone know where this one is? It's Maui, Hawaii. All right, and Alan?
So you've all seen lots and lots of data vises with like lots of dots on the map. In fact, there was quite a few in the keynote this morning. And what I'd like to do with the talk today with Anya is how do we take those dots on the map and make them a little bit more contextual. So a breakthrough with this context happened earlier this year. I don't know if anybody of you saw the New York Times a couple of weekends ago, or might have been last weekend, when there was a 25-page pull-out with every single building in the USA that they had taken some machine learning and Microsoft, and they have released it into GitHub. It's all open source. So now we have this wonderful, wonderful data repository of shapes that can represent those dots on the map. So the first dot, or patients, right? So the first case, you saw that dot in Maui, and now we can have all of these lovely buildings. But the next bit, of course, is what we really want to do is find all of the buildings and say, okay, of all these buildings, which is the nearest hospital to that building? So we use an open source tool called QGIS, and this is a plugin called NNJoin that you just go in, download. Free tool, and it will let you work out what the nearest thing is to the thing that you're analyzing. So it's very effective. And then, of course, how do you get from your house to the hospital? Well, you take a road. Unfortunately, we have OpenStreetMap roads, and we also have Tiger lines as well, which is open source, and you can download these, and you can start doing things like routing. So one of the things that I'm really proud about doing and releasing is we've got a tool in ALTERYX that we can do. We can call it our MAPBOX Directions API, which is works out all the routes from A to B. We also can do map matching, so that when we get all of the data of where these points are, we can match them to the map and to the road points as well. And there's everything that you see in this talk, by the way. Anybody who knows me, I haven't written a line of code this year for my presentation. So this is something that I'm really happy about, because we can use drag and drop tools to get to the result that we're after. And this is what it looks like. When you start doing mapping, when you're taking all of the buildings into account for Hawaii or any other state, and you work out what the nearest building is, then you can run through the ALTERYX algorithm, and it's going to return you the routes. Now, the reason that we did Hawaii is there's a very, very big difference, or a delta, between a straight line between the building and the hospital, and then the roads, which are, in many cases, very, very windy. They go up steep, the sides of the volcano. People live in rural communities, which are a long distance from the hospital. So when in most of our talks, we just think about straight line distance. So what we're able to do now is you can clearly see the difference between somebody who is living way out in the sticks there. It's on a rural road, but you can tell that the difference in straight line to the hospital and by the road is quite dramatically different.
All right. So Alan comes home with that, and I'm like, yeah, so what's the use case? It's very neon and pretty. Like, oh my God, Alan did a black map with neon colors. That never happens. So we started to talk about why is this relevant? And we came up with the concept of, well, if we know the distance, what we really want to understand is how long does it take the patients to get to the hospital? And there's this concept of the golden hour. If you can get a patient to a facility in under 60 minutes, they have a greater chance of being stabilized and surviving. So we decided to build the use case with our newfound distance information. But then I looked at his distance calculations and his miles calculations and said, but have you ever driven on the road to Hana? It is insanely windy and crazy.
No.
So, wasn't good enough. Wasn't good enough, baby.
No.
So, we took advantage again of the drive time.
Yep. You sent me off to MAPBOX and said, oh, it needs to be right. So I had to set up the driving profile with the API. And yeah, we were back and forth on this quite a lot. And Annie was like, no, it has to be right. It has to be right. It's not that, if I know that I lived way over here in Hana, which is in the far east of the island, and it's going to take me about 2 hours, but your thing said it's going to be, like, what was it, 69 minutes or something? So I was way off. Anyway, ran it through the MAPBOX Directions API, and we know that this is now solid. So I was able to give Anya an Esri shape file to load into Tableau.
With the drive times attached.
With all the drive times attached to the buildings, as a nearest neighbour to the roads, and Bob's your uncle, and she can now have a pretty looking isochrone with the right times.
And it's still not good enough.
Demanding.
Because at the end of the day, we're talking about patients, not buildings, right? So we want to understand our customers. And so another open data source that we wanted to take advantage of is the American Community Survey data, or census data that you're used to. And so here you can get an example of all the different things that you can look at. There's income, children, education, earnings, health insurance. And just here's my little animated GIF. Will it work? Like, yeah. Anyhow, but there's like, if you just scroll through it, there is just so much data out there that's available to you. Oh, there we go. There we go. Like these are all the, I'm just starting. Like it's every field you could ever imagine to describe things about people, and I won't play the whole thing because you see I've only scrolled down a smidge now, but using this data, that slide. All right. We decided to focus on things like health insurance data so we could better understand who has health care, what type of health care they have, in order to better build that in with our distance calculations and understand who we're serving. And using that American survey data, we were able to kind of build this understanding of the population of patients that we're serving, and we can understand by drive time distance and gender breakdown and age breakdown, who are the patients that we want to serve and where are they located relative to my facility. And I can zoom in on those patients that are at risk because they're in drive time minutes very far away. So I could understand when we get the call. You might notice that the language speaking is greatly reduced when we're moving out far away. These are people living in rural areas. So that might be a concern that we could address in order to better serve our patients. And all this is great. We have this spectacular dashboard with all this information. What did we forget?
People.
We haven't added in our customer data. It's our hospital. So we know the populations that we have served to date because we know their address and we can geocode it. And so now we can start to understand who are these patients that are far away and which are the ones that I have already served. And so I can proactively better address their needs if I know they have specific conditions and they're far away, figure out ways to reach out to them and make sure they can get the help they need even though they're very far away. Or I might look at the competition and I might see how else they might serve. So there's another hospital in Maui, and we've broken up the map by the nearest neighbor and distance to each of the hospitals so you can see who is closest to which facility. And once we do that, we're able to understand patients that are maybe further away from us but still go to our facility, and what's driving that is a specific specialty that they're taking care of. Is it perhaps insurance-based, and that's why they're coming to us? So it really allows us to understand our clients in relation to how we serve them or how they might be better served. Okay, and that was all from dots on a map.
Yeah.
All right, so that was our slow example. Our next one is going to be government and emergency planning, and we're in New Orleans, and we all know the hurricanes that happen here. And so once again, we're starting on a map. These are all the evacuation centers in New Orleans. And just so you know, you are there.
So we use, in the following example, we use MAPBOX Studio. We're able to take conditions in the data and color using things like quantiles, and We used expressions and data-driven styling with MAPBOX Studio, and it's really for cloud-based users. But we can get something like this. So we take the premise of the previous example, with find the distance to the nearest evacuation spot. And that's great because we can find, how quickly we can get there and that sort of thing. But
Still not good enough.
Anya says to me, we need a better use case.
So we know where people are running, but when they get there, will we have enough room to be able to accommodate them? So we kind of the situation of the Titanic life, are there going to be enough lifeboats? And so we look into the capacity of those facilities based on square footage. And we try to determine, based on the population that's rushing to that facility, will there be enough capacity to handle the need? And what we were looking at is the square meters per person at each of the facilities. And then we had this concept of theater capacity, which would be you in a movie theater. You're allotted 0.6 meters. So if people were packed in, and there's a picture of the Superdome during the hurricane, and everyone having a hard time getting accommodated. And then there's the FEMA guidelines, which was like 0.4 square meters per person.
Oh, and by the way, if you're in a federal prison cell, you get allocated 8 square meters.
Yeah, so twice what your FEMA spot is. So again, just this concept of starting with the buildings, starting with the population at the buildings and the evacuation, we're able to kind of enhance the analysis of capacity planning for these types of situations. Cool, our next one is finance.
Yep. So I get hold of lots of dots on the map at MAPBOX. I'm really happy in my job because we get some people that come along with us and say, hey, we've got this great data. How can we do anything with it? And a company called SafeGraph said, we have this thing where we see everybody in the USA every 15 minutes, like 10% of the population. I was like, no way, absolutely no way. You get. And it was true. He gave me a CSV dump of all of this data, and I was like, right, let me at it. And so, boys and their toys, lots and lots and lots of dots on a map, right? We're quite good at that, though. Anywho, for this, we thought about MAPBOX Atlas. This is our secure on-prem server facility. Because what we're doing is looking at dots inside of banks. We're able to use Tableau to intersect join so that any of the dots that fall inside the branches, the banks, the buildings that we know about, as in, there is a Bank of America branch right here. There's a Citibank right here. There is whatever. And because the data is so granular, we can see dots literally moving over time. We can see where the dots on the map cluster over the ATMs. We can see where they cluster by the tellers, for example. We can even see the clusters in elevators going up and down multi-level buildings. Quite insane.
But Alan comes home and again, yeah, it's not good enough. So we can take it down. Obviously, we have your data. We have things like the building footprints inside of your branch office. And we also have devices that are known to you. You have devices potentially that your employees were given that you know that they're part of the infrastructure, so you can monitor that behavior. You can also, for example, look at employee devices and maybe understand patterns. You can kind of see the 9 to 5 for most of them. There might be devices that are on continuously that are not part of your infrastructure. That might be an area that you might want to focus on. Or you might see just anomalous blips come up that are in, that's the safe, secure areas, and that might be of a concern as well. You can also do things like looking at support staff coming in after hours and understand if they're somehow appearing in the middle of the day. That might not be a normal behavior. And you can also use it to analyze customer traffic profiles. Are there customers that are coming in multiple times a day? Is there perhaps a better service offering you could provide for them? Or you could look at the flow within your building and understand if you could optimize the layout or how you're offering things. See if customers are standing there a long period of time in order to better serve them. Okay, and then also, of course, the nefarious devices that you just have no idea what's going on. All right, next one, retail.
Yep, so for this example, I think it was probably the one that I had the most fun with, because it was
Because we fought the most.
because we fought the most. We were like, what is it we actually want to do? Anyhow, we thought coffee chains would be quite interesting, and I'm pretty sure those that follow the data blogs, you know, the Nathan Yau's flowing data and stuff like that, have seen lots and lots of dots on the map as well with coffee shops and some good analysis here. Anyway, I just took the whole lot for Massachusetts. The reason I went for Massachusetts, by the way, is that it's the only state that has 5 brands of coffee chains in it, such as Starbucks and Timmy Hortons, even though it's Canadian, and Dunkin' Donuts. And we came up.
That's not coffee.
Yeah, it's not.
I crossed one.
So actually, we are starting a war, and that is the point of this this viz. So what we do is we have a technique that, if you've seen our stuff before, we use a technique called a Voronoi, which is basically a synthetic area, and everything inside that Voronoi is basically the property of the thing that is the dot that is in the middle of that Voronoi. So if in the middle of the Voronoi there's a Starbucks dot, all the buildings kind of belong to that Starbucks, right? Because it's the closest place.
But of course, that's not good. We wanted to take this analysis further and understand how to address market expansion and customer retention. So again, taking your data, if you are Pete's or your Dunkin' Donuts, you know who your loyalty customers are. Perhaps they have a mobile app on their phone, so you can start to understand where you have these loyal customers in pockets of Dunkin' Donuts territory. And how it may be better to keep them, but you can also use this information then to look at where you're not represented and where you could expand your market to better support customers that are traveling a far distance to get to you currently. Maybe you could serve them better, and look at the whole map and try and flip all of them to Pete's.
Yep. Yeah. Next one is hopefully going to give you a little bit of a fright. So I had a great time and a great pleasure working for ACLED in DC recently. ACLED, for those of you that don't know, is the Armed Conflict Location Event Database. Yep. Fabulous people to work for.
And we had the DC tug to hold it through a Visilathon to support them.
Yep. Just a fabulous group to work for. And their data is amazing. And as you can see right now, if you go onto the ACLED website, it's lots of dots on the map. So what I did, and I use a MAPBOX technology called TIPPECANOE here, which is a command line tool, but it's still not programming.
And this time I went first, and he gets to prove me. He's
I
the
already-
one at me.
Yeah.
So I had said, we always see all these dots on a map, but it's very hard to understand the overlap of these different actors. So we went and created a convex hull in order to create concave hull, to create kind of these shape overlap areas and define the boundaries of where the different actors are interacting. And it's just much easier to consume with those shapes than just looking at a billion dots that are on top of each other and you can't really see what's going on. Cool. Mm-hmm. And then Alan came home.
Yeah, and then I came back and I was like, yeah, that's okay. Anyway, what I did was think about what data ACLED were really interested in, and they wanted to know where the nearest telephone tower, the nearest cell phone tower was. And I was like, why? Why is that interesting to you? Well, when you do a line of sight analysis in GIS terms, what you're basically doing is you take the cell phone tower and you drop it on top of the elevation, and you say the event was like 2 meters high, because that's rough. I mean, I'm not 2 meters high, but it's roughly.
I am.
It's roughly the height of people. And what it's doing is it basically draws a line from the cell phone tower to that event. And if there's anything that's obstructing the view, then it can't be seen, right? Now, from that, what we're able to do is an analysis like this. So the blue dots here are the rebels, and the yellow dots are the Kurds. The Kurds are important here because they basically do the north and the east of, north and east, because I'm facing the wrong way, of Syria. And then the ISIS operate all over the country. The Russians and the Syrian army basically team up, and they go out as far out as the river Euphrates. But what this visit is showing us is that ISIS, they just stay off the map. They stay off the grid. They don't go anywhere near cell phone towers. They don't go into conflicts where basically there's any sort of level of technology. So we can draw a fairly safe conclusion that ISIS are not using LTE phones or 3G phones, but we're pretty certain that they're using satellite phones. So I'm not doing any kind of military analysis with this. This is just straightforward Tableau. We get this amazing data set from ACLED, and yet we're able to derive some analysis like this, which I think is kind of pretty powerful. Yep. So the next two.
He learned his lesson by now.
Yeah, it's this is taxi data, and one of the things that we like doing is where Tableau are headed with GIS. We think they're being incredibly forward-thinking. Like, you know, a couple of years ago, we'd never thought we'd actually be able to do things like spatial joins and intersecting in Tableau. It's just phenomenal. And then, you know, we saw density marks in the devs on stage last year. And now it's part of the product. It's just incredible. And it's both of these things that when they come into production with Tableau, you'll be able to do something like this taxi thing, but even better, because it'll be in the box. You won't even need to do any work in QGIS or Esri or MAPBOX. You know, it'll be there in the product. Anyhow, what we've managed to do here is, you remember the devices thing in Manhattan with the banks? So I got the same data set, but this time for San Francisco. So what you can see is a mashup of a straightforward calculation in Tableau just to get utilization, because Anya thought, well, we've got to have a use case, right? So I did a little bit of calculation in Tableau. And then the backdrop here is with the devices. But what I'm trying to do is basically say, no matter how big the data set and how complex the question is, we are now being able to attack this directly in Tableau without doing anything else. Because we can drop those dots on the map, the taxi dots. We can intersect them with the density map. And you end up with something that's actually, you know, quite useful for people that are doing work for Uber, Lyft. You can see where is your market, where is it hot, where's it not. And you can actually try and, you know, identify the one taxi driver down here, the red dot, who's basically sitting in the lay-by reading his newspaper all day. So it's kind of cool. And then the last one, which is probably the most mental one, is there is an open data set out there which is like cell phone data records. So these are basically from A to B, there was a phone call, right? And in an area of Italy called Trento, they have like gigs and gigs and gigs. One day is 45 gigs worth of data. I mean, it's absolutely massive. And it's literally just A to B, 1 or 2 or 3. That's all it is. So what the A to B is one of these dots. These are all little grids, and you basically draw a line like this. So it's like, okay, make it here, and B is over the other side. Anyway, we...
Oh, wait.
No,
Sorry,
right,
sorry,
right.
one, okay, sorry.
Yeah, it's all right. So again, we're touching on what's in the box with Tableau, and we're already seeing the new KML thing where they're doing geodesic, like great arc lines in the box without any fancy Christy Martini magic. And you're also, you're quite used to seeing hex maps and stuff like that as well. But we think what it might be useful for is when you have all these straight lines and they're geodesic lines and you've worked out all of the X, Ys and everything else, it's just a mess of spaghetti and it's absolutely useless to anybody, apart from the big enterprise customer that says, I've got to see everything on the map, right? And we're like, yeah, we can do that. We'll take your money. But it's much easier if you do something like this and you aggregate that data into hex grids. And I found this little plugin on QGIS, and it was you literally click 2 things, and it gives you hex grids out the box. It's amazing. So, with that being said, I think what we're trying to do here is go from something that's really simple, like a dot on a map, think about it a little bit, apply a little bit of math or logic or whatever, to come up with something that's inherently, I hope, useful. So we'd invite you to start thinking about this. I'm so excited about tomorrow. I'm bursting with excitement about tomorrow, about Devs on Stage, because we're going to be making an announcement. I'm not going to tell you what it is.
Because you get fired.
Because I will get fired. I'm under NDA and the secret site. But a lot of the problems that you've had with mapping literally go away as of tomorrow. All of these things that you see on the screen right now are available right now. What's coming tomorrow is just turn up. Just do me a favor and turn up to Devs on Stage, because it's going to be absolutely mind-bending and exciting, and you'll be able to use all these things and build fantastic things, and we just can't wait to see what you build with them.
Yeah, thank you.
Yeah.
That was it.
That's us.
Oh, yeah. Yeah, sure. Yeah.
Thank you, Anya.
Yeah, thank you.
Looks like we have a little time, so if anyone
we've got
wants
a ton
to
of
do
time.
Q&A, we can do some mic running and have questions and answers from Anya and Alan. And there's a hand up over here already. Sorry, we're recording, and so having your voice on the mic.
For the U.S. buildings data set,
Yes.
what attributes come with that? Does it tell you
None.
what kind of building?
There are no attributes. It's just pure GeoJSON. You have to introduce the attributes yourself. So if you want to calculate area, for example, you would use a field calculator and a GIS tool.
Okay.
If you wanted to work out the address of the building, then you would have to geocode. And
Like a reverse geocode kind of deal?
Yep, yep, absolutely. Uh-huh.
So do we want to remind people to fill out the survey only if you're nice?
So I was told to remind people to
And
only fill out the survey if you're nice.
I also want to thank everybody for climbing three flights of stairs,
You hiked for us, thank you.
which probably walked like almost a mile from the hall as well to here. So thank you so much for doing that.
And go to Chris and
come see
Tamasha's
us.
session next.
Anya, we have a question.
Hey guys. So I feel like the elephant in the room is the places where people use maps when it doesn't make sense. Like I see a lot of new Tableau users just double click on state, put a map on there so that people see a map.
But maps are sexy.
There's that. Maps are sexy, CEOs like them. But yeah, are there particular guidelines you use? Do you often just play with the map and then if it's not useful, go find a non-geo solution?
I think where Anya went with adding your own data, I think that really is
Capacity in New Orleans, right? At the end of the day, I didn't have a map. It was just where are people going to not have space?
right. Whereas we all work in companies that have address data for our employees, for our customers. And what you need to do is basically go, okay, that's an XY, but you've got to have a valid use case, like Anya says,
If it
to
adds
make sense of it.
context to the viz to see it spatially, then of course use it. But there's so much you can do by understanding that XY that doesn't need to be visualized on a map, right? We were able to bring in census data and all this other data just to support it, and it didn't need to be on a map at the end of the day. It's just who are my patients? What's special about them so I can better address and help them?
Well, in the end, some of these dashboards, you have the map, and then with other information.
Yeah. That's just because he wanted the maps for the booth at NOLA.
That's all it was. Yeah, it is eye candy.
All right,
But,
and
you know, there's a difference between drawing the eye candy but making it useful, you know.
They're all black and neon because they look
we have one
Sorry,
back here.
there's a question at the back there.
Hi, I have a question on.
Just speak really close.
I have a question on polygon intersection with the dot. Have you been able to do that successfully in Tableau?
Yeah.
Okay.
Yeah, so the thing to do is to have a point shape file and a polygon shape file, but they also have to be in the same projection. And I know when I start talking about things like the same projection, people just go, what is he going on about? Tableau uses EPSG 4326, which is Web Mercator. If both of those aren't in that projection, it won't join.
Okay.
But you can also pre-process in ALTERYX. or
Yeah, you can do a lot. Yeah, and I think you guys are doing projections in like in an hour or something.
I got a question too about what about if I wanted to do geospatial stuff like with MAPBOX or something, and I just want the data, but I don't want to actually visualize it. Like I want to be able to see what's inside a polygon and be able to just have that as data.
I don't know what your question is, sir. Could you repeat it?
Well, if I have points on a map and I want to
Uh-huh.
see they're inside a polygon, but I don't want to map it. I just want to be able to grab that fact of that it's inside a polygon or it's a distance from a polygon, so
Right.
that I could maybe use that as an attribute or a dimension or filter,
Oh,
but
got
not
ya.
necessarily for the map itself.
So there's a thing about adding additional data to a dot on a map, like such as the state or the district or the zip code or whatever. Is that what you're trying to?
Now, I guess I'm thinking more about geoqueries, that if I have a point, I can see that the point is in, I can do geoqueries to see if the point is inside of
Oh,
a
yeah.
particular map, right? And I can map that and I can filter it and so on, but how do is there a way in MapBox of just like pushing that, here's the points that intersect, if I want the points or I want the data elements, but not,
It can just be done
to
in
map
Tableau.
it.
It can be done in Tableau.
it could be done in Tableau
Yeah,
as
yeah.
well?
Yep.
Okay.
Yep. I think so.
Just the in-out set,
A
and
pr-
then that set becomes your definition.
I see, you use it.
Yeah.
Set, okay.
You don't call it in-out, you call it like good, bad,
All right.
or in-out.
I think we have time for one more. Anybody else?
Anyone?
Okay. I'll come back.
We have buttons.
What would you say is a good resource for starting out or learning with geospatial data?
Whoa, there's a lot.
That's
I-
why I'm asking, because there's a lot.
I-
What would you recommend?
I like geofabric.de is really cool because they do entire cuts of countries, and they do they kind of segment that further into the things that that there are. So you can kind of look at here's all the roads or here's all the buildings for entire countries, and I just love that. And the other thing is it's updated every single night. You know, so if somebody makes a change in OpenStreetMap, and then you go on geofabric.de and say, okay, I want to do all of Spain, and they have like, here's all the hospitals, and here's all the roads. It's an incredible resource. But the GIS community, you know, from an open source perspective, is just phenomenal. You know,
With the malaria work?
yeah, you know, and it's another community that the Tableau community is going to be part of. You know, I think Tableau is becoming actually, you know, usable as a GIS solution. And therefore, it's going to open doors to the GIS community, which have been, you know, so strong for so many years as well, and bringing those two communities closer together. I think it's an incredible opportunity. Yeah.
But you can also buy us Manhattans and we'll get you up and running.
All right, well, thank you everyone for coming and joining us in this wonderful session, and I hope that you all have a wonderful learning week at Tableau.